welcome again to another great video. So what will happen here is we are looking at a problem from KZN, and it was in March 2024. This one here, this question paper, right? So I took a very interesting problem from this past paper, which was 5.2, right? Still on Newton's laws. So check this out. We have this crane. It's lifting two blocks, and of masses 150 and 300 kilograms respectively. So seems like there was an issue here with this guy and that guy. I don't know, whoever said this made a mistake there, but that's not our issue. So if you were writing this, the teacher probably told you which mass to use, but in our case, let's use the one given in the problem statement. Okay, so we'll use the 200 kilograms. So now these blocks accelerate upwards at an acceleration of 0.75 meters per square second, right? Okay, so first thing we're asked to draw a labeled free body diagram to show all the forces acting on the 150 kilogram block. Okay, so that's usually an easy take with your marks. You just make sure you always get that one right. So let me just draw it here next to our diagram. In fact, I'll draw both the free body diagrams for the 300 kilogram block, or rather the 200 kilogram block, and then for the 150 kilogram block. So now let's start with the one that was actually asked, the 150. Right, so we have T1 going up, and then we have the mass of the block going down. Let's call it not the mass, sorry, the weight of the block. And then notice this thing is 3 marks, so it also tell you how much forces you need to have in your diagram, provided there's nothing extra mentioned, like maybe include the angles, right? Provided there's nothing extra like that. In this case, it was only forces, no angles, no forces at an angle, and so on. So you know for sure that your free body diagram has to have 3 forces in it. Otherwise, you won't get the full marks. Okay, so we only have 2 now. So we're only missing T2. T2 will be pulling the 150 kilogram block downwards. So let's just do this and make space for T2. Okay, this thing. Right, so T2 will be then fitted here as well. Doesn't necessarily have to be the same length as the weight of the block. We don't really know how big T2 is unless if we were given the magnitude of T2. So now this is the free body diagram for the 150 kilogram block. Okay, so let us then draw for the 200 kilogram block. Remember, we're calling this one 200 because we'll use the one that was given to us in the problem statement. So we'll have this. It will have T2 going there, and then it will have weight going there. Let's call this weight 2 and then this weight 1. Okay, so this is how it would look like. The reason I'm drawing it for each block respectively, even though it was not asked in the question, this one would be in my worksheet where my rough work is, and then this one will be on the question paper. Okay, so when they mark, they will give you mark there, and a mark here. So you will get 3 marks for all those 3 forces. We won't include this one, however. This is just for your own benefit on an extra piece of paper where you work out your answers. Now we move on to 5.2.2. so what is it saying? 5.2.2 is asking us to calculate the magnitude of the tension T1. So in this case, what usually happens is whenever you find a situation like this where you have 2 blocks that are connected by a string and are being pulled using a certain amount of force, and then they're accelerating, usually at a constant acceleration, like in this case. So you have two methods in which you can solve problems like this one. The first method is using simultaneous equations, which most people find to be the easiest. The second method is taking the overall system as is and then just solving it once. Usually that one involves less steps, just needs you to actually understand the concept. Right, so I'll try both methods for your own benefit. Let's start with method one. If you are satisfied with method one, you can leave the video and then you don't have to watch for method two, right? So let's try method one first. This is where I will use simultaneous equations. Right, so in method one, what you aim to do is you break down this thing. You start with block one, you take your Fnet is equals to MA, you go to block two, you take your Fnet is equals to MA. What you will notice there is you'll get two equations, and then at the end you try to equate or make subject of the formula the parameter that you're trying to solve for. In this case, you're trying to solve for T1. So let's go through it. Right, you have this method one, and this is for, well, let's start with the 150 kilogram block. Right, so remember, you always choose a direction. So I'll choose upwards as positive. Why? Because this thing is moving upwards, so it's convenient to choose upwards as positive. And I say Fnet is equals to MA. Right, so okay, Fnet is equals to MA. Okay, so now once we have that, we sum our forces. We're starting with what, the 150 kilogram block. The only force going up is T1. So since we chose up as positive, T1 will therefore be positive. Plus, both weight 1 and T2 are going downwards. So we will just make them negative because they are opposites to the direction that we regard as positive. Then we have MA. Okay, so this is what you would have. Then from here, this is where you would substitute your values. Right, you would have T1 minus weight 1 is just mg, which is 150 times 9.8, minus T2, which we currently do not know, is equals to 150 times A, which is 0.75. Right, and then from here you can say, well, I have this, I have two unknowns, since we're looking for T1. So if you come here, okay, let me just try and fit everything here and see what happens. Okay, so we are trying to find T1, right? So it means we must make T2 the subject of the formula, right? So therefore you will have, this is just maths. I will just skip to the final step where I have T2 as my subject. It will be T2 is 150, right? It should be that 150. So I get that 150 times that. Okay, so it should be T1 minus 15. I get 1582.5. So we can call this our equation 1. Right, that's fine. And then we go to block 2. So because this was for the 150 kilogram block. So we go to the 200 kilogram block. Right, we do the same thing. Fnet is equals to MA, we specify our direction, we sum, and we make the parameter that we're not looking for the subject of the formula. So let's get on with it. So we have, I'm still choosing upward as positive, right? Then I can say Fnet. Okay, then I only have two forces here. It's only T2, which is going up, minus the weight, which is going down. Remember, it's plus, and then the reason I write it like this is so that to show you why it's minus. So why it ends up being just minus W2 like this, right? We were summing it, and then W2 or the weight happened to be negative. Therefore, we just say T2 minus weight. Okay, so now we can make T2 subject. It means we'll have MA, which is 200 times 0.75. We transpose this to that side. Right? So once we transpose, we know that weight 2 is plus 200 times 9.8. Okay, then you can substitute and calculate. You can punch your calculator. So I get 2110 newtons, right? This is how much I get. So this means if we had started with the 200 kilogram block, we wouldn't have to label this as equation 1, because from here we were just going to go to the 150 kilogram block and substitute this value there, then we were done. So that means we can take this and substitute it in our equation. Remember, our equation 1 was just T2 is equals to T1 minus 1582.5, right? So now we substitute our T2, and we will notice that T1 will simply be T2 plus 1582.5, then therefore T1 is 1582.5, 3692.5 newtons. So this is what T1 is. This is our answer. Okay, so let's go to method 2. Method 2 is quicker. It's less tedious than this one, right? So it only requires you to understand why it's like that, in terms of why we do it like that. So let me just write it here. Method 2. You can use it for any system of blocks that are connected by strings together, like in this case T2, or the string. Let's call it this string 1 and string 2. This string connects these two blocks, right? For any situation where you have that, you can use this method. It always works, irrespective of whether the blocks are hanging or whether they are placed on a surface and then they are being dragged across that surface. It still works, or on top of that surface, right? So method 2, the way it works is, what you will do, you still choose a direction, right? And then at the interface, you ignore that tension, right? You just take it as if this was a system of blocks like this. You combine it to have one big block that is that constitutes, or actually that is made up of these two masses. So that means this one big block has 150 plus 200, right, which is the mass of these two blocks combined. So this one big block has the mass of these two blocks combined. And then you take, so if you have this whole thing, It means now the only force that we can see is the T1 and the weight of, the weight of this whole big block. So you only have these two forces acting on this big block. You won't see T2 anymore, right? This is how you would usually do it. So for this one, you still choose a direction. So you would still say, in my case, I choose up as positive, and then I say Fnet, right? If you're wondering why we choose to ignore the interface or the string connecting the two blocks, it's just in the way the free body diagrams are structured. So what we are essentially doing is we are taking two free body diagrams and combining them together. So if you check, I have this free body diagram, right? Let me mark them. I have this one, and then I have this one. If I combine them, T2s will cancel because they are in opposite direction, right? And we'll only be left with weight 1 and weight 2 and only T1. So that's essentially what we're doing, right? So mathematically that's allowed, and it's why we're doing it here. So we'll essentially have something like that. You have one big block. It means now our mass will be what? 350. Then we have T1, and then we'll have W, or the weight, right? So let's do it. We'll have T1 minus the weight is equals to MA. Now here you must also be careful. Remember, M is now the combination of both blocks, which is 350, right? So you must show it here. You don't just come and say 350. You must show it. You must add it here. So you'll have T1 minus, we have 150 plus 200. Remember, the weight is the overall weight of these two blocks times 9.8, right? Okay, this I'm unable to see. Yes, much better. Is equals to 150 plus 200 times 0.75. Okay, that's what we get. Now from here, you simply transpose. It means T1 is 350. I'm just factorizing, guys. Don't worry about this one. But if you punch everything in your calculator, you should be fine. 350 plus 0.75. You get 3692.5 newtons. This is what I get. So this is my answer. So let me check if it's the same as the first method. It is indeed the same as the first method. So this is how you would work out a system like this one. This was a very interesting question. So if you have more like this, please share them on the group, and then we will show you how to approach those. All right, thank you very much. See you on the next video.